Hello, everyone. This is Applied Statistical Analysis, week 12. This is going to be a shorter lecture today. Today we're going over moderation and mediation. We've talked about moderation a little bit before. We're going to introduce what mediation means. We're going to talk about why it's even important for you to know it. So first, mediation, it tells us about the path of an effect. We're going to illustrate this a couple times, but the idea is that in reality, one thing might impact another thing, which then impacts another thing. That's mediation. The effect goes from one variable to an intermediate one and then to the outcome. Jamovi doesn't currently support this with the built-in stuff, but there's ways to work around that. If you're interested in mediation more, we can talk about that. For this class, we're just going to introduce what it means. One way of interpreting the mediation is that the effect of x goes through m to y. In essence, x affects y because it affects m. On the other hand, you have moderation, and it's a synonym for an interaction. So this is something we've done with both ANOVA and regression, and Jamovi obviously performs it. You've done it before. And it's, when we're interpreting it, it's the effect of x on y depends on m. X isn't affecting m, and m doesn't affect x. M just changes how x affects y. This is a diagram of what moderation normally looks like. So the moderator isn't affecting x or y, but it's affecting the line between x and y. That means x is affecting y in some way, but the moderator changes how that happens. Conversely, you have mediation. Mediation is where you have x affecting m, the mediator, which then affects y. We also have this dotted line between x and y, and that is signaling that there may be some ways that x affects y that's not through the mediator. I want you to consider some examples. One is x could be bully victimization in early school. You can have this situation where an individual is bullied younger, and later on we notice that those that are bullied are often more likely to use drugs. But it doesn't really make sense to say, well, being bullied makes you suddenly want to turn to drugs. What actually people are showing is that being bullied hurts your self-esteem. The self-esteem is actually what predicts drug use. That means, for a number of reasons, that can be a very useful piece of information. For one, if we know someone was bullied growing up, we can't change that they were bullied, but maybe we can change their self-esteem. There are ways, there's treatments to help with that. And if we help with the self-esteem, then we actually can break the cycle, and it won't end up, that individual will be less likely to use drugs because we're kind of chopping this path. What this means is mediation is really useful for a number of clinical reasons. There's a lot of reasons why we can't stop a certain event from happening, like being bullied, although we can definitely try to reduce that. But there may be some ways that we can affect what being bullied actually affects, like self-esteem. And if we do that, we can reduce risk of poor behaviors and outcomes. So because Jamovi can't actually do this, most of the time you need somewhat specialized software like R. There are some side packages for SPSS and Jamovi to actually do this. So if you are interested, reach out. And for this class, you don't actually need to know the ins and outs of mediation. You're not going to be tested on this thoroughly. You're not going to be asked to actually perform this, but it can be really useful. So why are we talking about it? Well, for one thing, the world isn't super simple. It's not always a variable impacts an outcome and that's it. It's good to think about how things are actually happening in the real world. It also helps us think about confounding better. In this class, we haven't talked a ton about confounding. We've introduced the idea, but the idea is actually really important when it comes to using things like regression. There's always a chance that a third variable is in some way impacting the relationship that you're looking at. To help you think about this, I want to introduce you to the 4 elemental confounds. This is from Richard McElreath. He wrote a book called Statistical Rethinking. I really like how he talks about different ways that a variable could be a confounder. In this, we have 4 different ways that Z, the confounder, can impact the relationship between X and Y. So let's say what we're interested in is actually finding out how does X affect Y. And then we find out, well, there's this confounder. It might be getting in the way. If that's the case, we need to be thinking, what situation does it fall under here? So the first is the fork. This is saying the confounder is actually causing both X and Y. That X doesn't affect Z and Y doesn't affect Z. It just, Z is the ultimate cause of both of them. It's making both of them happen. It's influencing both. There's this relationship between chocolate consumption and car accidents. If we're considering, does chocolate consumption actually affect car accidents? We have to consider, how would that actually happen? How would chocolate make people more likely to crash? Here, what is actually happening is it's a time of year. So the time of year would be Z in this case. The time of year is causing an increase in chocolate consumption and an increase in car accidents. In this case, the fork is a type of confounder that we have when we're looking at the relationship between chocolate consumption and car accidents. But actually, those two aren't really related. It's only the fact that we have the time of year causing both of them. The pipe is just like mediation, what we were just talking about. So bully victimization would be X, Z would be self-esteem, and Y would be drug use. So self-esteem would be this third variable, and we would have to ask ourselves, is it caused by our predictor being bullied? And if so, then it might be the pipe. The pipe might be that exact thing. Similarly, the descendant is just saying, if Z causes something, then A is a lot like Z. A could be a confounder as well. The fourth one, the collider, is very different than the others. It is essentially saying that both X and Y cause Z. So any relationship that there is between X and Y is only connected if we have Z in there. If we don't have Z, then X and Y are no longer connected. They're just independent of each other. All of these others, we need to consider the fork, the pipe, and the descendant. We have to control for Z. In the collider, we actually don't. The reason why I introduced these 4 to you is anytime you're doing a study where you're looking at a relationship between a variable and an outcome, you always want to consider, are there any confounding variables out there? And if you think of one, it's really helpful to think, does it fit in as a fork, a pipe, a descendant, or a collider? And depending on which one it is, it can help you decide what you're supposed to do with your analysis. As a note, there's no application this week. We've already done moderation in the class, and we're not going to be doing any mediation. I just want you to think about causality a little bit more deeply from this lecture and think about whenever you're looking at a relationship between two variables, don't ignore the fact that there's probably a confounder out there, and you should consider what that confounder actually looks like. This can help you read the scientific literature in your field and understand, does this study look like a good one or a bad one, just based off of potential confounding variables. So if you have any questions, please post them to the discussion board before class starts. We can get to them and discuss them together. Thank you.